For today's video, I'm going to be talking about representing the division of fraction with models. All right, so let's just start with division of whole numbers. So remember, when we have a question that says 6 divided by 3, we have 6 of something, let's say cookies, and I'm dividing it into 3 groups. 1, 2, 3. So each group has 2 in it. All right? So it's like sharing. That's what division is, sharing. Insert sharing is caring here. So let's see how it works with a fraction. So first we're going to do whole numbers divided by a fraction. So I have 6 wholes and I'm dividing that into 1/3. So ultimately I'm trying to figure out how many 1/3 there are in 6. Now, and if I use a model to represent this, I've used a number line and I've represented 6 wholes on my number line. I've also labeled thirds, right? So this is 5 and 1/3. This is 5 and 2/3 along here. So now I can divide my 6 into thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I hope you were counting with me. So if I divide 6 into 1/3, there are 18 of them. Okay. I can also, let's try it again with dividing it in halves. So if I look, I know that 1/2 is in between 1/3 and 2/3. I'll put that on my number line. This time count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 divided in half is 12, which makes sense, right? Because if I think about 6 divided in half, 6 divided in halves, each whole has 2 parts. So it makes sense that you would double the 6 to get the 12. Now this works because it's one fraction, right? The numerator is 1. So I'm literally just counting how many of that fraction is in the whole. Now, what if the numerator is greater than 1? So let's try that. So we're going to divide 6 divided by 2/3. So again, I have my number line. I've labeled my 6 wholes. I've also labeled my thirds. But this time, instead of 1/3, each group's going to get 2/3. So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 divided by 2/3 is 9. Now, what do you notice? Do you see any relationships between the whole number, the fraction, and the answer? So see here, I notice 6 multiplied by 3 multiplied by 1 gets me 18. 6 multiplied by 2 gets me 12. 6 multiplied by 3 I know is 18, but I divided it by 2 and it gets me 9. And if I think about this logically, yes, if I divide it into thirds, each one of these, each whole is going to have 3. 1, 2, 3. So if I multiply 6 by 3, I'm going to have 18 1/3 in total. Same with the half. Each whole is divided into 2 1/2s. So I multiply these 2 together and I get total number of halves in my whole. Here, I started with my 18, but instead of it being an individual third, it's 2/3. So I divide it by this top number and I get 9 groups of 2/3. So that's a whole number by a fraction. And now we're going to talk about division of a fraction by a whole number. So let's say we have the fraction 6/7. I represented it here with a model, right? So I have my whole and I've divided it into 7 parts and I've shaded in 6/7. And the thing with division is that we're only working with the fraction of the whole that we have. So I'm not necessarily concerned about this 1/7 over here because I don't actually have it. The numerator tells me how many parts of the whole I have, and that's what I am dividing. Not the entire whole, just the fraction that I have. So I look at 6/7 and I know that 6 is divisible by 3. And so I know that I can divide 6 parts evenly by 3. So let's see here. 1, 2, 3. So if I divide 6/7 into 3 equal groups, each group is going to have 2/7 in it. And I've represented that with my model here. Now, when the numerator is divisible by the number, the division is somewhat simple. But what if it's not? So let's say we have 6/7 divided by 4. I know that 6 is not divisible equally by 4. I could get into, each person gets 1 1/2 of a seventh, and and it gets further complicated that way. Or I could find a way to make the numerator divisible by 4. So this is where a misconception comes in fractions. For the other operations, we're focused on making things equivalent, the denominators equivalent. And in division, we're looking to see that the numerator is divisible by the quotient. So I'm first going to start with common multiples. If I'm familiar with my multiplication facts, I can do this simply in my head, or I can start writing them out, right? So 4, 8, 12, 16, I can keep going. And then 6, 12, 18, I can see a common multiple. So I need to make this numerator value 12, because I know that that will be divisible by 4. So what do I do to 6 to get to 12? I multiply by 2. But whatever I do to the numerator, I must do to the denominator. So I'm going to multiply 6 by 2 and 7 by 2 to make an equivalent fraction. So is equal to 12/14. So now I have 12/14 divided by 4. Okay. I know that 12 is divisible by 4. So what do I do with my model here to represent this new fraction? So I have my whole divided into 7, and I've shaded in my 6/7. I now need to make this into 14. So I'm going to divide each one of these halves, each one of these wholes in half. It's a little confusing because there's that center line there. Try to ignore that. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 equal parts. And of those parts, I have 12, which is what's shaded here. I'm going to divide those 12 parts by 4. I know that 12 is divisible by 4. 1, 2, 3, 4. So I know that each person, in each group, there's going to be 3/14. So there's representing the division of fractions with models.